All right, let's get started. Good morning, everyone. Um, this is a discussion of risk analysis and analytics with Safran Risk. I'm Ian Nicholson. I'm VP Solutions at Emerald Associates. I'm a risk analysis trainer and consultant. I've worked in many different industries doing risk analysis. I started doing risk analysis on cost estimates when I was an engineer on construction projects back in the 90s. And I started working on schedule risk analysis as the Canadian PERT Master reseller in 2001. So I've been doing this a very long time, longer than I care to think about. I'm going to go through Safran Risk today. If you have any questions, please feel free to put them in the questions section and we'll cover them at the end. We should have time to answer any questions that you may have. Um, Joining me is Marilyn Backstrom, an implementation specialist with Emerald Associates, who also does a lot of work in risk analysis. So, why would you conduct risk analysis? Well, risk analysis helps project teams and executives understand and manage the risks on their projects. Most importantly, it gets the project team discussing the challenges of the project and where things are likely to go wrong. Keeps the project team focused on the right issues. There's always a lot of issues. We need to identify which are the ones that are really going to come back to haunt us. Risk analysis is the requirement of many companies' gate approval processes. And more modern risk tools like Safran Risk help us understand the dependencies between cost and schedule. Now, I'm in Alberta. A few years ago, there was a report done by the Construction Owners Association of Alberta, who reports every couple of years on the status of projects in our part of the world. And they found that project risk assessment is shown to significantly reduce project costs. So ask yourself, do you build detailed CPM schedules? Do you develop detailed cost estimates? Well, of course you do. Everybody does. But the chances of meeting your project schedule and financial goals are still typically a lot less than you realize or would like. Well, how can this be? Well, we do detailed CPM scheduling, but there's a problem, and that's that the data we enter is in finite values rather than ranges. So we'll say that job's going to take 4 days with 3 people at $100 an hour. Well, the problem is the assumptions change over time, or maybe they don't match reality. Maybe they never matched reality. And things change. We plan to do that work in the middle of summer, and now we've got to do it in the middle of winter. So instead of taking 3 people 4 days, it's now going to take 3 people 5 days. Or we estimated this 5 years ago when the price was $100 an hour, and now the price is $150 an hour. So things change, and we need to make sure that we're building those uncertainties into our models. We do detailed estimating. But the problem is, a lot of times estimators are encouraged to be either too optimistic or too pessimistic, particularly when we're in a bid process, which encourages aggressive estimates. Estimators may also add their own contingency. We've all been on projects where we've had a contingency line item and someone's removed it because they say, oh, you don't need that. What do I have you for if I need to have all this contingency? So they remove it. So what estimators do, well, they hide the contingency. Um, and estimates are built on historical experience that may no longer be valid, or the estimates may be based on a smaller or larger project, which may not scale to match the project we're currently looking at. So these things are all deterministic. So what's the problem with that? Well, deterministic values don't take uncertainty into account, and uncertainties can build on one another to make our end project very different from the one we originally envisaged. There's uncertainty in everything we do. I mean, the classic example is, I can't tell you exactly how long it's going to take me to drive to work every day. Some days if I go on a Sunday morning, it'll take me 15 minutes, but on a busy weekday, it might take me half an hour or 45 minutes. And there's just generally things like traffic and catching all the lights the wrong way or an accident. All those things may impact my drive to work. And yet, I'm going to say that I know exactly how long it's going to take to build this project in the middle of nowhere that I've never built before. So historically, there's no easy way to model cost uncertainties with our schedule. So that's the other thing that happens is we've built cost models, we've built schedule models, but we've never managed to link the two together. Now, what we really need is a probabilistic cost and schedule risk model to help us understand exactly what's going on in our project. Again, going back to the Construction Owners Association of Alberta, they found that on average, Alberta-based mega projects, and that being projects over $1 billion, experienced a 19% project cost growth and a 17% project schedule growth. Now, we all know that cost and schedule are intrinsically linked. The problem is, how are they linked and where do we have flexibility? And that's what we need to understand. So we need to be able to model our schedules and costs more accurately. We need to limit our financial exposure. We need reproducible results. We need a repeatable methodology and audit trail. We need improved likelihood for project success. We need confidence in the results. We need buy-in from the team members so that they actually believe the results and can action them. We need to increase the maturity in conducting our risk analysis. And we need to get everything in a common database so we can go back and look at it later and understand what went on. So, out in the market, there's a number of risk tools. Safran being a relatively new entry to the market, this tool came out in about 2015 and really matured in about 2017. Um, but it's a great tool because it allows you to do ranging on estimates, allows you to model your key risk events. It allows you to tie your cost model with your schedule, um, and allows you to build uncertainty into your logic in the model as well. So all of those things together let us understand the probability of achieving our dates and costs. And in this case, we don't want to understand the dependencies between them. Um, we want to understand the key drivers and their effects. We want to run scenarios, and we want to be able to run mitigation strategies and understand their impact on the overall schedule. So let's take a look. So I'm just going to share my screen here, and hopefully it works. We had a webinar last night where the screen share wasn't working at all. Oh, good. So it looks like my screen is being shared. So this is what Safran Risk looks like. So first of all, you'll notice that I've got the ability in here to import a project file. So I can import a Microsoft project file or a Primavera P6 project file, or I can import a project file from Safran. I can also, it also shows me a list of the recent projects that I worked on. The nice thing about this is instead of building on a bunch of flat files like the old PRA tool would do, this actually works on a SQL Server database. So we've got a good, robust database backend that we can store our data in. Now I'm going to open a project called UAV Prototype. So this project is an unmanned air vehicle. Um, People call them drones. Of course, we hear all about them right now, being used in the war in the Ukraine. Now, these things have to be developed, they have to be tested, and eventually they have to go to market. So here's a simple schedule around the development of one such model. Now, the way Safran works is we start off with a bunch of tabs across the top of the screen, and we work from left to right. You notice that there's an Analyze tab here, which is green. Now, the Analyze tab basically separates our inputs, all the tabs prior to that, from our outputs, which are all the tabs after. So it's very much workflow based, which makes it very easy for new users to get up to speed because they just work through the tabs as they go. Now, Safran Risk is built on Safran Project, which is a full-featured scheduling tool. In parts of the world, particularly in Europe and in the Middle East, it's a competitor to P6. It's not used so much in North America, but it is a fully featured scheduling tool. So one of the nice things about this is I can make changes in here. I can make logic changes or resource assignment changes or anything like that that I need to do. I can do it right here, and I can have my changes immediately reflected in the model. I don't have to go back to Microsoft Project or to P6 in order to make a couple of small changes. Okay, so without going into any great detail here, um, Let's move on to the next tab. So the next thing that the system shows us is any schedule warnings that we might have about our schedule. Now, you can spend a lot of time getting a schedule kicked into decent shape to do risk analysis. As one of my mentors used to say, scheduling is garbage in, garbage out, but risk analysis is garbage in, toxic waste out. So we really want to make sure we have a good, solid, robust schedule when we start. Now, Safran will let you um, see any issues that you may have with your schedule, things like open ends or constraints or um, you know s- funky logic like start-finish relationships. It will identify all of those, and we can fix them before we do the analysis. Now, the nice thing about it is that it will let me go to any of these particular activities just by right-clicking on it and saying "Go to." And then I can fix the problem. And then I can, as soon as I fix the problem, the schedule warnings tab will update. So I can just work through this list to make sure that I've gotten rid of all of these things that might be an issue. And I can tell the system what I care about. Do I care about constraints? Do I care about lags? Do I care about relationships? So I can tell it to watch for things or not. If there's something that I don't, that I'm going to accept and I'm okay with, I can just mark as accept, and that doesn't really do anything in the system except flag to me that I've already accepted these things and I don't need to look at them again. So, when you start off, you might have 50 or 60 items. I looked at one the other day that had 800 items that showed up here, mostly constraints. But as we work through them, we could just check them off as either being done by removing them or saying, yes, we accept that this is something we have to live with. Ideally, we don't want to end up with a whole lot of constraints because that'll prevent us from getting a good analysis. Now, once our schedule is good and solid, we can then move on and we can have our project risks. So the idea here is I want to have all of the risks that are impacting my project, both cost and schedule risks, in one place. I don't want to have some stuff on activities and some stuff in my costs and some stuff in a risk register. I want to have it all in one place. And the reason for that is obviously I can manage it more easily because everything's there. And so I can look down the list, and if something's missing, I can add it. But also, it lets me drive my results back to these risks because everything starts from a risk. So when I'm looking at my tornado charts and things like that, um, I can I can very quickly see if there's going to be or what the impact of that particular risk is going to be, both cost and schedule wise. So let's take a look at the risk types. First of all, we can have standard risks. So a standard risk is your typical risk. It can have a probability between 0 and 100%. Um, I can have probabilistic branching. I can have existence risk as to whether an activity exists or does not exist. Um, and I can also have an estimate uncertainty risk. So we'll talk about the difference between each of these as we go, but let's just look at one standard risk here. So this particular risk has a 40% probability of occurrence, and it has a cost and schedule impact. So I've modeled here that when it fires, it has a relative impact, and I can put in a relative or an absolute impact. It has a triangular distribution, although I can choose any particular distribution shape that's appropriate. In this case, I've chosen a triangular distribution shape, and I've said this is what the shape is going to look like. So if it fires, it's going to have a minimum impact of 100% of my deterministic duration, and it could be as much as 165% um, impact on my overall duration. Now, I can also put in a cost impact. Now, in this case, I can put a value in from a negative value up to a positive value. In this case, this is probably a strange one. So let's just say that it's going to be between let's say 10,000, and most likely it's going to be say 12,000, and our worst case is going to be 15,000. So it's going to look something like this. So again, this is an absolute impact, so this is going to be in dollars. Now, I can also have a pre-mitigated and a post-mitigated position for any particular risk. Now, this is really useful because what I can do when I'm working through my model and I'm working with the project team is I can define a different pre-mitigated and post-mitigated position for each risk. So I can also record what I did to get to my post mitigated position. So I can record a schedule impact or a cost impact to get me from my pre-mitigated position to my post mitigated position. Okay. So this is very useful when I start doing my mitigation strategies and my what if analysis to understand which mitigation strategies are worth doing and which mitigation strategies are not worth doing. Now, once I've entered the risks, then what I can do is I can map them, and I'm going to map them to my schedule. I'm going to come back to the cost mapping in just a couple minutes. But initially, what I'm going to do is look at how do I map these risks to my schedule. So the first thing is that when I've got my activity, so I've chosen this particular activity, prepare the contract. Now, you'll notice that there's two sections of risks here. There's the ones on the left of this heavy bar and the ones to the right. Well, the ones to the left are estimate uncertainties. So the idea here is I can choose a low uncertainty, a medium uncertainty, or a high uncertainty, or no uncertainty at all. But what I can't do is I can't choose more than one of them. As soon as I select one, it turns the other one off. Now, when you think about it, that makes a lot of sense, right? I'm not going to have low cost uncertainty and medium cost uncertainty on the same element. It's going to be one or the other. Now, the next thing is that I can choose my standard risks. I can choose as few or as many as I need to. So I could choose, in this case, go back to prepare a contract. I've got e-communication, I've got governance, I've got procurement delays all selected on here. Now, one of the things that's really powerful about this is that Safran will immediately show me the impact of all of those risks. So here are the risks that I have on this particular um, activity. So I've got governance, low uncertainty, e-communication, and procurement delays. And here's what the overall impact looks like. Now, this is really good because if I'm in a situation where I'm adding risks and I'm building the model, if I add something that's completely out of range, so maybe I've got a 30-day activity and I put a risk on there that's got a 300-day impact, I would see that immediately on here. So if I add another risk, so maybe I go in here, this is prepare a contract. Maybe I say, you know what, merger or acquisition is a big issue for us here. That could impact the overall project and would impact my procurement process. As soon as I select that, it immediately, let me move this little guy out of the way, it immediately redraws to show me what that new impact is going to look like. So again, as I turn them on or off, the system immediately redraws so I have an idea of what my impact is going to look like and I can make sure that it makes sense. Now, once I've got all my mapping in here, then what I can do is I can actually run the model. Now I'm going to come back to the cost model in just a moment. So I'm going to skip this tab. Um, I'll talk very briefly about correlation. Now what I can do with correlation, and I'm going to turn off a few of the boxes here, is I can map the probability and impact of one risk against another risk. So for example, I could say, okay, if I have internal communication issues, I probably also have external communication issues. So I could correlate those two risks together, saying if one of them happens, probably the other one's going to happen as well. I can also correlate the impact of those. So if one of them has a big impact, the other one's probably going to have a large impact as well. Um, so let's look at, we're going to run the model now. Now what I'm going to do is I'm just going to set it to run 1,000 iterations. Um, and I've got some options in here. I can do things like I can say include or exclude correlations, resource level after each iteration. I can step through the model, which I'm going to do. I can also tell the system that I want to run my risks in a pre-mitigated position or in a post-mitigated position. So for example, on that ash cloud risk, I could say, you know what, let's run that in the post-mitigated position because we've done our mitigation work and we already know what it's going to look like in the post-mitigated position. So I could flip that to run in the post-mitigated position, or I could even turn it off completely if I want to run a scenario without that particular risk. So I'm going to turn it back on here. So I have that capability to mix and match, and that's very powerful because oftentimes you want to be able to run one risk in a pre-mitigated position and another risk in a post-mitigated position. And it used to frustrate us in working with Primavera risk analysis because it had to be all or nothing. So we'd end up having to make different models to build those scenarios. All right, so we're going to run the model. Now, because I have the step through shown, it's going to take me to the Gantt. Just move this over a little bit. And just like I would do in most other tools, I can just step through and make sure things are happening the way I expect them to happen. Again, what I'm looking for here is anything that's not making sense. If I click through and, for example, I've got an existence risk on an activity and that activity never appears, or I've got probabilistic branching defined and the branches never happen, then I can fix the model before I go any further. In this case, stepping through, things are moving pretty much the way I expect, so I can hit complete. And the system's going to take me to my distribution graph. Now, in the distribution graph, I can see the results of my overall model. So it's going to show me, you thought you were going to finish on the 21st of October. There's only about an 8% likelihood of that occurring. Well, what does that mean? Well, that means that in our simulations, 8% of the time we finished on or before that deterministic finish date. Now, if I want to get a little more confidence, like maybe I want to get up to, say, a P70 confidence level, um, I would need to give myself about 4 months of contingency to take me from October 21st up to February 14th. So in that case, uh, 70% of the simulations finished on or before February the 14th. So I could be comfortable in saying that's the amount of contingency I need to get up to that level. Now, if I was to move up, if I wanted an 80% confidence level, 80% of my simulations finished on or before the 3rd or the 7th of March. So that would give me that confidence level. And the system tells me to get from your deterministic date to your P80 date, you need about 138 days of contingency, which represents about 23% of the original duration of the project. Now, this is all configurable. I can go to different highlighters. I can change the curtain to show different ranges. All of that's fully configurable. Now, sometimes though, I don't really care about the overall project because there's closeout activities and cleanup activities and demob activities all at the back end of this project that I don't really care about. What I care about is when do I turn this thing over to the customer? So there's a couple ways I can do that. I can go in and I can choose any particular activity in the schedule and see the results for that particular activity. But I can also create what are called focus activities. And the idea with focus activities is I can define some intermediate activity or milestone that I care about and look at what the results are for that. So maybe I've got some milestone which is, hand this thing over to sales, or maybe it's transfer of care, custody, and control from this plant we've just built to the owner. So in this case, um, I can focus in on that particular activity and not worry about all the stuff that comes afterwards. Now, I also have the ability in here to look at the results. So what I can do is I can say for each iteration, what happened? So if I sort this by my duration, let's go look at the whole overall project rather than that one activity we're highlighted on. There we go. So what it says is in iteration 810 was my shortest duration of 551 days. And it shows me which of my risks fired in that particular iteration. And it also shows me, did they fire in a positive or negative way? So the box represents my schedule impact, the dollar sign represents my cost impact. And what this says is these risks fired, and they all fired in a positive way. They're green. Whereas if I look further down, maybe at this iteration down here, you can see that design fired there too, but the box is red to say it fired in a negative way. So this is quite useful because I can say, okay, in my best case scenario, what happened? And then I can also look at it and say, well, what happened in my worst case scenario, which was 963 days? So almost double my best case scenario. Well, here's all the risks that fired in that iteration. And I can even go further and say, okay, let's look at that iteration by clicking on it. And it will actually take me to the Gantt chart and show me exactly what happened in that particular iteration. So I can see what's firing, what's happening. It's really useful if you're trying to track down why you've got a couple of iterations that are quite extreme in their values. Let's go back to the distribution graph. All right, so that's my distribution graph. Well, I can also look at my tornado charts, which are my drivers. Now, remember before I said that it was really powerful that everything goes back to the project risks tab, because now I can actually look at which of those risks are having the biggest impact on my overall schedule. So in this case, the ash cloud was having the biggest impact with an impact of 0.618. Now, I'll come back to that in just a moment. But I can also look at it and say, okay, which activities had the biggest impact? So not only can I look at what are the risks driving the project, but I can look at what are the activities that are driving the project. And just like before, if I want to look at that focus intermediate milestone, I can do that as well. So I can say, what are the risks driving that intermediate milestone? And what are the activities driving that intermediate milestone? So again, lets me focus in on a particular area. Let's go back to the overall. Now, one of the things that often happens is we look at this and say, okay, in this tornado chart, our correlation for ash cloud was 0.618. Our correlation for testing overrun was 0.42. And so to me that says, okay, when my ash cloud goes long, my overall project goes long, and the correlation is about 0.62. Okay, good. That kind of helps me. But inevitably, the project team says, you know what? That really means nothing to us. You say it's 0.62 and the other one's 0.42. What does that mean? And I could say, well, it means that one's about 50% greater than the other, but that's never going to satisfy the project team. What they want to know is, how many days is that risk costing me on my project? Well, Safran has an answer for that, because under the next tab, the sensitivity analysis, what I can do is I can look at the impact that each risk is having on my project at a selected confidence level. So let's take the P80 confidence level, and I'm just going to make sure this is set for single pass. And what I can say is calculate the impacts. And I can look at it on the overall project, or I can look at it on my focus activities. So let's look at the overall project and say calculate the impacts. And what the system does is it actually runs through and does an analysis by turning off each risk in turn. So it turns off the first risk, looks at the results, turns off the next risk, looks at the results, turns off the third risk, and it goes all the way through doing that. Now, in Primavera risk analysis, a lot of my clients used to do this, but they would do it manually. They would go in, turn off a risk, run the model, turn the risk back on, turn the next risk off, run the model, record the results each time. And it is miserable work to do. I mean, it's tedious, it's just soul destroying work. So it would always end up getting passed to the most junior person on the team, and pay your dues and all that sort of thing. But the result is useful because it will tell us, okay, I can go to the project team and say, okay, that ash cloud risk that we said was at the top of the tornado, at a P80 confidence level, it's costing you 34 days on your overall schedule. So if I can get rid of this risk, I can reduce this from 30, I can get rid of this 34 days. Now, this one's an ash cloud, right? So we're saying we're doing some testing, and there could be an ash cloud that's going to impact our testing regimen. Well, maybe our solution is we just go test this thing somewhere where there isn't a volcano nearby. So we could completely eliminate this risk by going somewhere else. Now, maybe that's not likely, but there's not a lot else we can do with an ash cloud. It's not like we can stop a volcano from erupting. But our mitigation strategy could be, let's go somewhere else. Then it'll tell us, okay, the next one, poor flying conditions. Okay, so poor flying conditions due to bad weather could cost us 33 days. Well, again, maybe we go somewhere where we're more likely to have better weather. The part of the world I live in, Alberta, they trained a lot of air crew in World War II, because we typically get good weather here with high cloud, and you get probably 320 flying days a year here. So let's go test it somewhere else. So anyway, we can answer that question for the project team. We can give them the answers that they need as opposed to the answer that's easy for us to calculate, which is a correlation factor. All right, so now I'm going to step back and I'm going to talk about cost. And as I mentioned before, I see there are a couple questions. I will get to your questions at the end. So if anybody has any other questions, just type them in the questions or the chat section. I will get to them at the end of the session. All right. So historically, as I mentioned before, we build a schedule risk model, we build a cost risk model, and the two of them never come together. Um, so many years ago, I worked as a lead scheduler for Shell on a project, and I was the schedule manager, and there was another guy who was the cost manager, and we both reported to the project controls manager. And on a quarterly basis, we both had to do risk analysis. And we would send the results off to somebody in Shell corporate who, in theory, would put the results together and produce their own result. But we never saw the results. It didn't make a whole lot of sense. So what we tried to do, this cost manager and myself, is we would sit down and say, okay, let's see how we can put our two models together. So what we did for a little while was we would build a cost loaded schedule. So we would take all the cost estimates and all the estimates to complete, and we build them into a resource loaded schedule. And that worked, but man, it was hard. I mean, getting those things aligned all the time and figuring out which costs, should be on a milestone and which costs should be on an activity and how they were impacting and all that sort of thing. It was a lot of work to build. Um, so people tried that and generally got away from it. So the next thing that people did was they would take the results from from the schedule analysis and they would build them into the cost analysis. Well, that also worked, except that now you're taking results from one model and feeding them into another model. So effectively, you're building a simulation on a previous simulation, which tended to give um, a narrower range of results than what you would like to see, or that would be accurate. And David Hewlett did a white paper a few years ago on why you're going to end up with essentially a truncated result from doing that. I think that white paper is on Safran's website. So, so although it worked again, it wasn't giving the kind of results that people were hoping to get. So Safran looked at that and said, well, you know what? We have a bunch of customers and we're looking at the market and we're seeing that people are using Primavera risk analysis for schedule and they're using at risk or crystal ball for cost. What if we just put it all in one package? What if we let people do a cost risk model in our tool? So what they did is they came up with this cost module, and the idea is you can build your own cost model in here. So you can put in, how many units do I need? Or sorry, you can put in the cost of per unit. You can put in how many units you need. You can even put in things like exchange rates and things like that to come up with a total cost for a line item. And you can put uncertainties on each of those items. So I can say, okay, my base cost is $123,000, but it could be anywhere from 98 to $180,000. I'm not sure. This is transportation, so I think I'm going to need 3 shipments at $120,000 each, but maybe I only need 2, or worst case, I might need 6. I could put an exchange rate in there and say, well, you know what? I expect the exchange rate to be 1 to 1. Maybe it's, you know, um, euros to American dollars or something. But you know what? It could range anywhere from zero point 0.9 to 1.2. So I can build all of that into my model. Also, what I can do is I can link my risks to the model as well. So if I go under this section here where I've got my testing resources as a line item, so it's a $300,000 line item, I could also link my risks to that. So I can say, okay, you know what? Of all the risks that I have in the project risks tab, these are the ones that have cost associated with them. So if remember, we looked at the Ash Cloud one, it had a cost associated with it. Any of the ones that have costs associated with them are available here, so I can assign them to my cost line items. So now when I run the model, it's going to look at those base uncertainties. It's going to look at any of the risks that I've assigned to come up with an overall cost. But it even goes a step further. It also allows me to link this to my schedule. So what I can do is I can say, you know what? My labor items are going to be schedule related because if it takes longer to do the work, it's going to cost more money. Now, my material costs probably not so much. I'm going to buy the material. The material's there. If it takes longer to do the work, probably not going to take any additional material. So what I can say is, okay, some of these cost line items I'm going to link to the schedule, and some of them I'm not going to link to the schedule. I'm just going to turn those columns on so we can see them. All right. So the way that works is I can take any particular line item. So let's take this one for testing resources again. And I can say, I'm going to link some portion of this cost to my schedule. And the way I do that is I pull up my schedule and I can say, okay, this item here, which is my testing resources, is going to be linked to this activity, final on-site testing. Now I can link it any amount from 1% to 100%. And I can link it to more than one activity as well if I need to. So maybe there's 5 or 6 different activities that all represent this work, and I can add as many as I want as long as the total doesn't come to more than 100%. Now, when I do that, in this case I've said it's 50%, what the system does is it says, okay, you've told me that 50% of this line item is linked to this schedule. It looks at it and says, okay, my variable portion, this was a $310,000 line item, is $155,000, looks at the deterministic duration of the activity, which is 40 days, and says, okay, my day rate is $3,875 per day. Now, when I run the iterations, what it's going to do is it's going to recalculate this variable cost every time based on the risks that are firing and the uncertainty that I have in my cost. And then it's going to calculate the day rate based on the deterministic duration of the activity. And then it's going to say, okay, but in this iteration, this activity has now gone to 50 days. So my cost would be my day rate multiplied by my current iteration duration. So in this line item, my risks are impacting it, my uncertainties are impacting it around the cost, but also half of that is being applied to the duration of the activity. And as the duration of the activity goes longer or shorter, my costs there will change as well. So this is really powerful because what it's allowing me to do is it's allowing me to say some of my line items are schedule related and some of them are not. So that gets around the problem I always had before of, well, I got to build this whole resource loaded schedule, which is just a nightmare. Or I got to take the results from one model and feed them into another model. Well, this model's running all together. So I don't have to do that either. So this is just beautiful from the perspective of let's put it all together. Now, when I go to my analyze, I'm what I can do now, I'm just going to add more iterations here and I'm not going to take away, well, I'll leave the step through on so we can see what happens in the cost model. So I'll say run analysis. Now it takes me to the Gantt, but I can just move to the cost module and I can see here, if I go up to the top, I've got this iteration value, which is my total cost for this iteration. And as I go through, you can see that each iteration it's changing and my risks that are firing get highlighted and they gray out when they're not firing. So in this case, testing overrun is not firing in this particular iteration. And I can just keep working my way through and I can see what each of these iterations is resulting in my overall value. And when I'm happy with it, I can hit complete. Now, if I go to my distribution graph, I see what the same thing I saw before, except that now what I can do is I can click to move from the schedule analysis to the cost analysis. So here's what my overall cost is looking like. My deterministic value of 8.4 million is coming in about 20% likely. If I want to get up to 80%, I need to add about $500,000 to get me up to about 9.1. So maybe $700,000 to get me up to about $9.1 million. Now, similarly, I can look at a focus cost if there's a particular cost element I care about. So again, I can choose particular costs that I care about, maybe my labor cost, and I can take a look at just that particular area. And I can follow this through by looking at all the other tabs. I can look at my drivers tab on a cost basis. So I can say, what are the risks that are having the biggest impact on my overall costs? Well, my highest one is my design risk, followed by my outsource risk. And I can also look at the sensitivity analysis, and I can look at that on a cost basis. So in this case, it tells me again, looking at the overall project, the cost impact on the overall project at P80, here's what my cost impact is looking like. So my design specification change is costing me $196,000. My transportation quantity risk, where I was going from, I said I thought I'd need 3 shipments, but maybe I only needed 2 or as many as 6. That's costing me $150,000. And again, same idea. I can work my way down and tell the project team, hey, this is what these risks are costing us. But here's where it gets really interesting. I can look at a scatter plot. Now, the scatter plot is showing me where I'm likely to end up in each dot represents one of the iterations of my model. Now, I was looking before at my P80 confidence level. So it was about 20%. I was about 20% likely to achieve my deterministic cost. I was about 8% likely to achieve my deterministic finish. Now, when I look at the overall results, though, the probability of achieving both of them is about 3%, which kind of makes sense because 8% times 20%, it's going to be a pretty low number. So it's saying about 3% of the time I was successful in both cost and schedule. Now, we all know that a project isn't successful if it's on time and over budget. And similarly, a project isn't successful if it's on time, or sorry, if it's on budget, but it's late. What we need both of these to be achieved in order to be successful. So we call this the joint confidence level. In other words, where do we need to be to have to be confident at some percentage that we're going to achieve both. So in this case, let's say I want to look at an 80% confidence level. So the 80% confidence level is right where I move from the orange band to the red band. And you can see here that it's actually not a straight line. What it is a curve. So it starts off vertical and then it curves down here and then eventually it becomes horizontal. Now, what does that tell me? Well, where it's vertical, it's telling me you can spend all the money in the world. You're not going to save any more time on your project. Where it's horizontal, it's telling me you can give up all the time in the world you want. You're not going to save any more money. So, but in between, in this curved area, I've got options, right? So I could say, okay, you know what? Time is much more important to me than cost. I really need to get this thing to market. So I could choose this point here and I could say, okay, that says I'm going to finish on March the 28th at a cost of $9.5 million. But maybe really it's all about money. We're running out of money and we can give up a bit of time. But we need to save money. Well, I could choose a point over here that'll put me at about $9.2 million, but it's pushing my project out until June. So anywhere in between where it goes vertical and where it goes horizontal, the project team can trade one against the other. So the project team can determine, we want a P80 confidence level. What do we need where do we need to be in terms of cost and schedule? Okay. So this is very powerful because you can do this kind of what if analysis. You can say, okay, if we run this mitigation strategy that's going to cost us $100,000, but it's going to save us 2 weeks, is that worth doing? So you can rerun the model make very quickly within Safran and do a lot of scenarios. So very, very powerful from that perspective. Okay, so let's take a look at the questions that we have. So the first one is, can we have constraints and lags in the model? Yeah, absolutely, you can. There's nothing to stop you from doing that. The model won't break. However, if you've got a must finish by constraint, the activity will not move beyond that point, and mechanically the tool will still work, but you may get results that are not accurate. So you always have to be aware of the impact of constraints on the model. Now, one of the things that's really useful when you're actually building the model is to do that step through so you can see, hey, what's this constraint doing to the model? These activities are all moving, but they're not stopping. Similarly, there's nothing to stop you putting a start finish relationship in, even though a lot of people consider it poor scheduling practice to use it. There's nothing to stop you doing it. The system will still work. It just you just may get results that you don't expect. Another question here: when I import Microsoft Project into P6, I have different dates in P6 than in MSP. Um, so this issue will exist anytime you end up moving from one tool to another, um, uh, because they have different scheduling engines. So they're going to get slight differences between them. So to give you an example, uh, when we used to bring files from P6 into Primavera Risk Analysis, we'd often get this cascading variation that would come in. And the reason for it was that P6 supported half hour calendars and Primavera Risk Analysis did not. So every time you had a half hour calendar, you'd get this half hour error in the calculations. Safran does give you a very useful layout when you do an import that shows you a comparison of the results coming from P6 and the results coming from Safran, so you can see if there's any issues and you can fix them. But it does happen, and usually it's around calendars and things like that. So it's something you always want to check before you run the model. So there's a question about what is a relative impact versus assuming that means versus an absolute impact. So a relative impact, if I look at this, a relative impact means it's going to take the original value and multiply it by the percentage that you define. So in this case, if I had an activity that was, say, 10 days, it would be a minimum of 10 days, most likely of 10 days, with a maximum of 16 days. So in this case, or 17 days, because it's 165%. Whereas an absolute impact would be in absolute units, which would be either days or dollars. So in this case here, where I've got an absolute dollar impact, this would be $10,000, $12,000, $15,000, regardless of what the original deterministic value was. So you do have to be careful when you're using absolute impacts, because if you apply them to a number of activities in series or a number of cost items, you might end up um, overestimating the impact. So you just have to be aware. Like if you take an absolute schedule impact of 10 days and put it on 10 activities in a row, when it fires, you're going to have 10 times 10 days of impact, which will give you 100 days of impact. And maybe that's more than what you were expecting. Um, there's a question about the distribution shapes. Probably beyond the scope of this webinar, in terms of which one should you use. We have a bunch of different shapes in Safran. You can use triangular distribution, a uniform distribution, which means all results are equally likely, a trigen distribution, which extends the tails of a triangular distribution. You can have a normal distribution, um, a cumulative distribution, which means you can define your own shape essentially. You can have a discrete one where you can only certain values can exist. You can have a beta pert or pert shape, um, log normal, or you can develop a split triangle, which means you've got a different upside and downside risk. So all of these are available within the tool. Which one should you choose? Well, that depends on that really depends on what you're trying to model. Um, I I typically would use a triangular distribution, a uniform distribution, or a trigen distribution. Those are the ones that I use the most. However, depending on what I'm trying to model, I may use a different one as well. So if I'm trying to estimate, for example, how long it's going to take concrete to cure, well, that's a natural thing, so a normal distribution would make sense. Anything that occurs in nature follows a normal distribution. Um, so kind of depends on what you need. Unfortunately, there's no easy cut and dried answer for that. All right, so let me stop my screen share, go back to my slides. If there's any other questions, feel free to stick them in the chat or in the question section. I'll make sure I get them answered. So there's clients all over the world who are using Safran Risk. Um, It's been really a very successful project or product for Safran. It's really filled a niche, and they've had a lot of clients, particularly in the uh, nuclear industry and in the oil and gas industry. They've had a lot of success in those industries in particular. Um, so at this point, um, I'll open it up to any other questions that anybody might have. I'm not seeing any right now. All right, so here's my contact information. If you do have any questions, you can reach out to me. Another question just came in, said, in which situation would you choose to map the post mitigation rather than the pre if the overall output is pre? So maybe you've built a model that has a certain impact, um, and then the project team, by the time you've actually you've done the risk workshops, they've identified something, and this happens quite often. um, so the project team comes out of the risk mapping section and says, "Hey, wait a minute, we this is something we really should think about." And they sit down and they come back to you a week later and say, "Hey, you know what? We've already figured out a solution to this risk. So what we're going to do is we're going to, you know, I don't know, we're going to hire a different contractor for this part of the work because the first guy we were going to hire, he didn't have a lot of experience, and for slightly more money we could hire somebody who has a lot of experience. So to mitigate this risk, we're going to change this scope of work to this other contractor, for example. Well, in which case you could immediately flip the model to the post mitigated position. You could say, okay, going to the other contractor is going to cost $10,000. It's going to take an extra week to get them mobilized, but here's what the impact is going to look like when we're done, and you could rerun the model. So you have the ability to very quickly um, flip between the pre and post mitigated position. And the idea there is to let you understand what's happening in the real world, right? Because things are fairly dynamic. So the idea is we can very quickly update the model with a new value. Now, the decision may not have been made to do that. There might be a solution that the project team uh, has suggested. We could go to a different contractor, um, in which case there you have two scenarios, right? You stay with who you have and evaluate what that model looks like versus running this pre post mitigated position on that one risk and see what that model looks like. So it just gives you a lot of flexibility in how you run the model. All right, so my contact information is here. If anybody has any other questions, feel free to reach out, and I'll be happy to answer any questions you might have about Safran. Um, we also do offer training for this product. So if you're interested in getting trained up on Safran Risk, we typically run our training classes every second month, um, and we can do them specifically for a client. Like if you have a group that you need to get trained, we can do that as well, or we just do the open training. So it's all available if you want to get up to speed very quickly on Safran. And with that, we'll end up. We're 5 minutes early, so good timing. So thanks everybody, and have a great day. I look forward to hearing from you.